This is the presentation that I did at Dreamforce, showing our framework. We were using this framework for 2 years. Yeah, 2 years, but we open sourced like 1 month ago. My name is Leonardo Berardino. I'm principal developer here at Groundswell. And the first question is, why did we build this? Why did we build a framework for Salesforce? And Salesforce basically has a lot of features to avoid developer code. However, we have complex projects, very, very complex projects, and sometimes we need to use Apex. As an example, even with flows, we have clients that have huge automations with flows, but we need to develop Apex helpers for the flows to help to work to the business logic, to avoid limits, to avoid problems, because they start to have problems running a lot of flows, calling flows, and doing things and inserting data, and reaching limits, and doing all kinds of crazy things for crazy projects. And for this case, we need to develop sometimes Apex to help the flows, or sometimes an integration or other kind of complex projects. And this is why we thought about the framework. But what was the main problem? Basically, I think everyone had this problem before, just deploying code and waiting, and after 30 minutes, something failed. And what you need to do? Fix the problem, run again, more 30 minutes. 30 minutes is a good time, but there are projects that is 1 hour, 2 hours to run, I don't know, thousands of unit tests. And this is why we start to think, we need to do something, because usually with complex projects, we have a lot of Apex. When we have a lot of Apex, we have a lot of tests. And a lot of tests just creates this another problem that's a long time to deploy code. It's good for one side, not the time, but having a lot of tests, because this is ensuring the quality of what we are deploying, right? The Apex, having a good coverage of the code. However, sometimes we need to deploy something fast to production, and waiting 30 minutes and something failing, it's not good. And what is the problem creating new tests? Usually we have complex data models. And with complex data models, if I have a test that I need to test that product consumed, I have an Apex that inserting that product consumed, I need to prepare the data that is necessary for the unit test. In this case, sometimes I need to insert, in this case, 10 different objects, records, to allow my test to run, right? And when I'm running a unit test, I need to insert the data. I can use the test setup to do it. However, if I have 300 tests and the 300 unit tests are inserting data, I'm doing this 300 times. And you can imagine databases and slow resources, not in memory. You need to go through the network. We have the latency, we have the performance of the database, and so on. And this is one of the big problems when we have a lot of tests and a lot of data that's being inserted during the unit test. And this is causing the 30 minutes, 1 hour, 2 hours to run the deployment. Okay, and this was it was some problems that we had in some project that we received, and we start to think, how can we improve unit tests, how to improve the performance for these clients? Because we're receiving the projects and they are asking, you can improve this, and you have a lot of techniques to use, and one of the techniques is this one, and that I'll explain today. And we start to have a lot of improvements. Some clients from the 30 minutes to 10 minutes, as an example, is a huge improvement. But before talking about the framework, I need to explain a difference of 2 types of tests. We have the integration test and unit test. I think you listened to me saying unit tests, but usually what we call unit tests, they are not unit tests. Usually what you are doing is a kind of unit test mixed with integration tests. This is causing the problem with the performance with the test. And what is an integration test? Basic integration test tests the application as a black box. The integration test calls the API, calls It's like simulating someone from outside the application, calling the application, and this integration test will ensure that all layers inside the system are being called, are working well together, and also the external resources like external services, databases, and so on. And you can see here the integration test doesn't know what's happening inside. It's just calling the application, calling an API, calling a controller, and the system is doing their job, and the integration will test if that business rule or that logic was executed correctly. This is the idea of the integration test. But inside that application, we have this complexity here. And when the integration the integration test runs, the integration test calls that entire set of code or layers, or we can call it of any names, but behind the scenes, under the hood, it's calling a lot of Apex. It's calling the Apex or the code responsible for the API. It's calling the service. It's calling the selector. That is calling the database. That is running the trigger. Is running validation rules, flows, workflows, and process builders. And this is what integration test is doing. It's calling everything that is between the integration test and the database or the logic that's being called. And this takes time, because it not only takes time to run all this code inside the org, but also to call the database or call an external service. And if you multiply this for 300 tests, you can imagine how long this will take, right? But the integration tests are very important. I will talk about this after explaining what is a unit test, what is a real unit test. Okay, this is the same stack that I showed in the previous slide. However, thinking about unit tests. Unit tests, the idea is to test that unit, that specific class, that specific piece of code, not test the entire application. And in this case, you can see I have one unit test or a couple of unit tests per layer, per block. And I need to ensure that when I run in the unit test, one block, one layer is not calling the next layer, and also not calling the database. And how can I do it? This is one thing that we need to solve, because if I'm calling the selector will call the database. If I'm calling the service that calls the selector, what will happen? The service will call the selector that will call the database. I need to use some technique to decouple these layers, these blocks, okay? And here is the way that we can do it. We can use this technique called mock classes. Basically, I can create a fake class that will replace a real class. In this example here, I have this service. This service has these 4 dependencies. This service to execute the code, to execute the business logic inside, needs to call this service, to call this service, to call the selector that probably will go to the database, and call this unit of work here to run a DML. Okay, and we can see here that we have 4 different dependencies. And how can I create a unit test for the service, that orange service? First, I need to decouple this guy from the other dependencies. The unit test here, when this unit test run, I cannot call this dependency. And what I need to do basically is decouple. Using some technique, decouple here these dependencies. And how can I do it? Replacing the real dependencies here, the service replaced by a mock, a fake service here, a fake selector, a fake unit of work, and so on. And when the unit test run and call the service, what will happen is, instead to call the real class, like the real selector that is going to the database, the service will call the fake selector that will simulate the database, but will not go to the database. Okay. But this means that I need to delete all my integration tests in my org? No, because I need to work with both, because both are different tools. Unit tests are meant for one purpose, and integration tests are meant for another purpose, right? And you can imagine, if I have currently in my production 300 tests, and all are calling the database or running code that's calling not only databases, process builders, flows. I can reduce this for 20%, 30%. That will be integration tests that will real test all layers. You call the database, you call the process builder, because I need to test everything working together. And I can replace the other 70% by integration, by unit tests. And this will reduce a lot the time when I'm deploying the code when I'm running the tests. Okay, and this was what motivated us to create the mocking framework, because Salesforce has an API for stubbing. Usually people don't know that exists this API, because it's not easy to use. It's a very, very powerful API. We can do a lot of things with this API, but it's not easy to use, right? We can create mocks. I can pass real class to this mock, to this Stub API, and the Stub API will give me back a fake class. I can record statistics regarding that class, how many that class has been called. I can replace a returning value by a method. I can do a lot of things. However, it's not easy to use. If I need to use, I need to implement that interface. I need to go, when I'm creating my tests, I need to stop to create my unit test, think about my logic, and create a new class that will implement that stub provider that will help me to mock the data, right? This means that I'm not have focus on the logic, the test logic, but I need to create something external, a tool that will help me with the test. It's like if I need to do some kind of job, I need first to create the tool to do that job. It's not what we want. We wanted to use something that will help us to mock, to create the unit tests without needing to create the tool to do it. This is why we created the mocking framework. Okay, and you can see it's very low level. It's not easy to understand. You need to implement this interface. You need to understand this method and all these arguments here that are being received, and it's not easy to use. This is the documentation, the page that if you search on internet, by the Apex Stub API from Salesforce, we'll see this page here that explains how it works. And there's some examples here, but like I told you, it's not easy to work. Okay, and this is why we created the mocking framework and how it works. This is important to understand how it works. First, the idea of the mocking framework is to encapsulate this complexity. You can see here, the mocking framework is not creating something new. It's just helping you with some tooling that will create a layer over the Stub API. You don't need to worry about the complexity of Stub API. You can use the GS Apex mocking framework. It's an easy way to use the Salesforce Stub API. Okay, and it's the first version, but it's doing a lot of things. And one thing that this guy do is you can pass a class to the mocking framework. You give back the mocked class, the fake class, and also you can start recording behavior for this class. You can say, oh, I would like that my fake class return this value, or I would like to understand or to count how many times my code is calling the fake class. And you can imagine if I have a DML inside a loop, I can use the mocking framework to say, oh, that DML is being called 5 times. And it's a little weird, a code that I'm testing is calling DML so many times because I'm increasing the use of DMLs and I can reach the limits.
Right. And I'll show you step by step how to use it, some feature that it has. Okay, now I'll explain step by step how we can create the unit tests using the mocking framework. Okay, this is the scenario that I'll use for expanding the mocking framework. I have a payment service here. The payment service has 2 dependencies. I have this invoice selector. And what is the payment service is doing is using the invoice selector to get the invoice from the database
and sending this invoice to the payment broker client that will call the payment broker to execute the payment. Okay, this is the scenario, and here we need to replace these two classes by the fake classes to avoid that problem that I was talking about when we are creating a unit test. I don't want it to call the external resource. I don't want to call the dependency, right? The first step, like I told you, the payment server will go to the invoice selector. The invoice selector, you get back the invoice. The invoice will be sent to the payment broker. The payment broker client will send the payload to the payment broker. You perform, execute the payment, and the payment will be executed, okay? And some questions that I have for my unit test. Has the payment broker been called once? You can imagine if my payment service has a bug, it can call the payment broker twice and can execute the payment twice, and this is not good. Has the payment broker received the correct invoice? Or this invoice that is being received here is being passed correctly to here, or this guy is doing something, this payment service doing something wrong and passing the wrong invoice to the payment broker. This will create a problem because I'm collecting a payment for a different invoice that is being requested. Okay, these are some questions. And how can I implement the unit tests for this case? First, I would like to talk about this way to organize tests. I like to divide my tests in 3 steps. I have my tests, and I like to divide in given, when, then, or arrange, act, assert. The first part, I'm preparing what I need for my tests. The second part, I'm running the test itself. And the third part, I'm asserting what's being done and checking if everything is okay. And this is the part that I'll use for the example I'll show you. Okay? Okay, the first step, arrange. And here I have the scenario I was talking about. I have the payment service. I implemented that unit test in green, right? The first step is I have the invoice, right? But I don't like to get the invoice from the database because I'm creating a unit test, not an integration test. And I need to get this information from memory. I will create the invoice in memory. And how can I do it? And here I'm showing step by step inside the unit test. Please, if you have any question, you can just raise your hand and ask me, right? First step, I'm calling the mocking framework, right, to generate an ID for me, because I'm not going to the database. I'm simulating a database call, but I need to have an invoice that has a real ID. And I can use the mocker to generate ID and saying, oh, for this invoice here, give me a real ID. This will be an ID like we have from when we insert an object into the database, the same type of ID. Okay, following the rules from Salesforce to generate an ID. Okay, I have the invoice, the ID for the invoice. Now I'm creating the invoice in memory, not from the database. And basically, as an object in memory, I'm creating an object, setting the data, right? The total amount, the state, the invoice ID, and now I have the invoice in memory. Second step, I have the invoice in memory. I need to mock the selector because the real selector will not see this invoice in memory. If I call the real selector, the real selector will go to the database, and there is no invoice. When I run the test, there is no invoice inside the database. Okay, and I need to replace that dependency. Sorry, forgot to say. I need to create the mock. I need to replace the dependency because the payment service is not calling the mock; it's calling the real one. I need to create the mock and replace that dependency. And how can I do it? First step is saying asking to the framework, mocking framework, to start stubbing. I'm saying, oh, I will start to create the mocks and I'll start to record the behaviors. Second step, I will ask the mocking framework, give me a fake class, a mock class for the invoice selector. And here you can see I have an instance of this selector, but not the real one. Is the fake one, the mocked version. Okay, but this guy is not doing anything because it doesn't have code. It's a fake class. And how can I implement or can define how will be the behavior for that fake class? And this is the next step. I can call the mocker again, the mocking framework, saying when the getInvoice method is called with this ID, I would like that to return the invoice in memory. Okay. This is replacing the code that is inside that getInvoice, the real getInvoice. And when the payment service call the the selector, this invoice will be returned here, right? And the next step is replace the real instance, the real dependency by the mock one. And I'm injecting here the mock framework replacing the real one. Okay? Any questions here? Okay. No question? Okay, I have the invoice in memory. I have my fake invoice selector. I replaced the dependency. Now the payment service, if called, the selector will not call the real one, will call the fake one. And I recorded behavior that when the get invoice method from the invoice selector is called, the mocked class will return the invoice in memory, not the real one. Next step is do the same thing for the payment broker, because I don't like to call the external service when I'm running my unit test. I can do it when I run the integration test, but not for the unit test. Okay, same thing. I will mock the class and I will replace the dependency. How can I do it? The same thing. First line, I will ask the framework to mock the payment broker client, and I will have the mocked instance here, the fake instance, or the fake class instance. Here I will mock I will call the framework to mock the process payment. Is the method that will be called by the payment service, right? And you can see that I'm not passing the method inside the when here like I did in the previous example. Why? Because this method here is returning void. It doesn't have a return. And due to a limitation on the Apex, I cannot pass void methods as arguments, okay? But how can I do it? I can call it before the moment that I'm recording what I want, right? I'm calling the method state for, this is saying to the framework that I would like to record a behavior for this method here, right? And here I'm calling the framework. When this method is called, I would like to record everything that's happening with this method inside this recorder here. This means that inside this recorder, I will have everything that happened with this method, okay? What was the argument received, how many times this method has been called, everything will be recorded here inside, okay? I will show you why I'm doing this in the next steps, okay? Here, the same thing, I'm injecting the mock, replacing the real dependency by the mock version, right? And I'm done. I mocked the selector, I mocked the client, and I record the behavior I want that these mock classes execute. And what I need to do now, I need to stop stubbing. Okay, I don't need to do anything more for preparing the data that will be used by the class that I will test, okay? Next step, act. I prepare the data, now I need to really execute the code, right, that I'm testing. The unit test will call the payment service. The payment service will call the fake selector. The fake selector will return the invoice that I stored in memory. Okay, I'm not going to the database in this case. And the payment service will receive that invoice and pass that invoice to the payment broker client. Okay, the mock version. And here's the code. Pretty simple, right? I just create an instance of the payment service running the method under test. Okay. Next step, assert. Now I will check if my code is doing what is meant to do. Okay, what I expect that expecting what needs to be done. Okay, and here I have again the questions. Okay, for the first question, has the payment broker been called once? Do you remember the recorder that I got from from the mocked payment client. Here I can go to the recorder and ask how many times that that client has been called, that method has been called, and the recording will count how many times my class executed that method and return. If it's more than one, we'll complain here because I'm asserting only one call. Okay. And next step, has the payment broker received the correct invoice? And the same thing, I'm getting from the recorder the information from that first call, right? Because the payment service is calling the payment broker client, right? It's calling the client. And here I'm checking if the client has been called once, and what was the invoice that the payment service passed to the client. And again, from the first call received on the client, what was the argument received? What was the invoice received in that argument? And I'm checking here if the same invoice I have in memory, comparing both. Okay, I'll show you this in the code as well, running. Okay, these are some features that we have. I show you how to create a mock, pretty easy to create a mock. How to record the behavior. If I want a method returns a specific value, I can define what the value will be returned. And also I can check if a method in a mock has been called or what are the arguments received in that call. And this helped me to check if everything's happening correctly. And more important is this is pretty fast because this is happening in memory. I'm not going to the database, I'm not going to external service, everything is in memory. And if you remember that model that I showed you with 10 different objects, you can imagine if I need to run the code to insert that data, it'll take a long time to do it. And this is pretty fast. Okay. Here we have some other features that the framework has. One is, do you remember that I can mock the return value by from a method? In this case, the selector mocked get invoice. I can return different invoices depending on the argument I'm passing, right? I can record this behavior. When the get invoice method is called with this ID, I would like to return this invoice here. But when the same method is called with this different ID, we will return this second invoice. Okay, this means that I can record different behaviors for the same method depending on the argument received. Here another example, if I would like to ignore here the argument that is being passed, I can set with any values. This means that independently of the type of argument or the value that I'm passing here, the get invoice, the method will always return this same invoice here. Okay. I can also simulate an exception, right? This is sometimes hard because sometimes we have a try catch that is meant to catch exceptions from the database. But how can I generate an exception from the database? It's not easy, right? And here I can simulate an exception, right? I can say, oh, if this ID here with 333 is passed to the fake class, the fake class will throw this exception here. And here I can easily simulate an exception, okay? Other behaviors that I can record is I can define, instead to checking the recorder if the method has been called once, I can define saying, I would like that this method get invoice fail the assertion if it's called more than once. And I can define this when I'm recording, right? Or I can say this method should never be called. This means that when I assert the information, the framework will fail the assertion because if this method is called more than once or more than 0 times, you fail automatically. This is the QR code for the article that I wrote regarding the JS Apex framework. There are other examples. I am explaining in more detail how it works. It also has a link for the GitHub page. If I have any questions, you can ask me, or you can go to the GitHub and contribute if you want, if something missing. Okay, and thank you.